Hi everyone, today I'm going to be showing you the derivation of kinetic energy. Now let's look at the equation. Consider a body of mass m in kilogram with an initial velocity u in meter per second, which attains a final velocity v in meter per second after moving through a distance s in meter. Now how do we determine the kinetic energy? Now the first thing we need to do is to recall our equation of uniformly accelerated motion. Now from one of the equation of motion, we have that v square is equal to u square plus 2as. Now let's call this equation 1. Right, now in this case we are going to make a the subject of the formula here. So how do we make a the subject of formula? We can say v square minus u square is equal to 2as. So this implies that 2as is equal to v square minus u square. Let me rewrite this, minus u square. Alright, since we are making a the subject of formula, we divide both sides by the coefficient of a, which is 2s. Then we divide this by 2s, so that a can stand alone. X cancel s, 2 cancel 2. So we have a is equal to v square minus u square over over 2s. That is that. Now we can call this equation equation 2. Now we also need to remember from Newton's second law of motion. Now from Newton's second law of motion, from Newton's second law of motion, we have that F is equal to m a. That's F, force is equal to mass times acceleration. But from equation 2, we know that a is equal to v square minus u square over over 2s. So in this case we can call this equation 3. So we can substitute equation 2 in equation 3. So this will give us F is equal to m into brackets v square minus u square over over 2s. Right, now having done that, because when we're talking about kinetic energy is also equal to work done, so in this case we also recall from definition. You also recall that work is equal to force, right, times distance. Right, now if work is equal to force times distance, then okay, let's call this equation 4 so that we will have something to recall. If work is equal to force times distance, then it implies that w, can say w is equal to f times x. Don't forget, from equation 4 we have that f is equal to v square minus m into bracket v square minus u square over 2s. So we can therefore say that this implies that work is equal to what is our force? M into bracket v square minus u square, right, over over 2s, right, everything times times x. Right, now in this case s we cancel s here, so let me divide this particular region. Then we can say, since s is that, then we say w is equal to m into bracket v square minus u square, right, close bracket, over over 2. So which we can also write that m over 2 into bracket v square minus u square. Right, now if you remember, you also have to note that we have to recall again. We have to recall that work done is equal to kinetic energy. What am I saying? That for a body to move, you have to do work on that body. And of course, when you do work, you know that your force must move that body through a distance. Since motion is involved, that's why we can say that work done is equal to kinetic energy. So we can therefore, this implies that W is equal to what? E subscript K. E subscript K actually represents what? Kinetic energy, which is equal to what? M over 2 into bracket V square what minus what U what square. Don't forget V is the final velocity while U is the what? Is the initial velocity. But we can also assume, we can say, if the body is assumed to start from rest, right? If the body is assumed to start from rest, it implies that we can say if the body is what? Assumed, right, to what? Start from what? From rest. So it implies that U, which is the initial velocity, is equal to 0. Anybody starting from rest, the initial velocity is 0 because it has not moved any distance. So this implies that kinetic energy in this case will now be what? M over 2 into bracket V square minus 0 square, which is the same thing as saying what? M over 2 into bracket V what? Square. So we can therefore say that the kinetic energy of a body which is assumed to start from rest, please don't forget this condition, is very vital, because there are some cases whereby we use U if the body has actually moved some distance. So in this case, we can say that kinetic energy will now be what? M what? V square over 2, which can also be written as half what? Mv square. Half mv square. That is actually the proof. I hope this video helped. I would like you to subscribe to this channel. There is a message after this video for you to encourage more of this video. Thanks for watching. Bye.